Okay, it's a new unit on logs, and to start with, I want to just show you why you would need a log. In our last unit, we did exponentials, and we had things like we have a start value of 5, and then we have a doubling, which is 100% growth, because you could write this as like 5, 1 plus 1 is 2, right, to the x. So there is a typical, 100% growth. You started with 5, and then the challenge would be like if there is an x in the exponent like that, and I tell you that this is 8, then how are you going to solve for the x? 8 equals 5, and then this 1 plus 1 is 2 to the x, and then you divide by 5, and then you'd be stuck right here. 8/5 is equal to 2 to the x, and you didn't have a good way to solve it. That's the moment where you have to have logs. Well, you don't actually have to have logs. If you had a graphing calculator, you could graph this part, and it's one of the best strategies for the ACT. Whenever you have a really tricky equation, you can graph both. Y equals this, y equals 2 to the x, you know what that looks like. And you could graph this, y equals 8/5, that's a little more than 1. And you see where they cross, and that's the answer. All right, that is a way you could solve it. But what I'm supposed to tell you here is that you need logs to solve that kind. So everybody write this one out. I can give you a really simple one. 5 to the x equals not 25, but 26. Now, would you agree the answer must be close to 2? Because 5 squared is 25. It's got to be just a little more than 2. So I can tell you the answer to this is like 2.1, but what if I needed it exactly? That's what a log could do. All right. So now, let me tell you how to write a log. These are logarithms. I believe that you had a teeny tiny bit in higher algebra, but it is humanly possible. This is the first time you've ever seen a log. I don't know. It depends on which level of higher algebra you took. I'm like 90% sure that the kids that took honors higher algebra would have seen logs. I don't know if regular higher algebra does this or not. Maybe you can tell me. Have you ever seen something that said log? Have you? Some people are saying yes, some people are saying no. Okay, all right, you're gonna learn it now, and it's not that bad. It's actually a really powerful branch of math. So log base 5. Now, of these three things here, would you agree that one is a base because it has an exponent? Have you ever heard of that terminology before? I mean, I know you guys know that that's an exponent, but did you know that that's called a base? All right. Now, this other one, never had a name. It was just the answer. Well, we've got a name for it that we're going to use when we write it as a log. This is called exponential form. You've seen it. We just had a whole chapter test on it. You learned a lot about exponentials. But we got to be able to write exponentials as logs. And that number that's here, that goes down as the base. The next thing you do is you go over here to the 26, and that comes next. Do you get how we jumped to the other side? We did not do the x. Do you see there is no x yet? And then the last thing we do is we come back to the exponent. So we say equals x. Now that is something that your calculator could do. Now I don't want you to do it because it's not worth taking the time to grab your graphic calculator. I'll tell you, I'll type it in for you, and I'll tell you what that answer is. It's just log base 5 of 26. And if I do math alpha math, it brings up the log with a little base, and it's got a little box here, and it's got a little box there, and I type in 5 in the base, and I type in 26 in the other spot, which you don't know the name of yet. And it's actually 2.024. So the answer to this comes out to x, that thing, is 2.024. So just a little bigger than 2. Like we kind of knew it was going to be a little bigger than 2. But I thought it'd be like 2.1, and it's nowhere near that big. It's actually quite a bit smaller than that. All right. Now you might be like, well, what good is this if you had to have a calculator to do it? Like, let me give you this example. There were logs that were used when they were putting a man on the moon. You know, like when we had to actually do a bunch of computations to get people up onto the moon, and yet nobody had a handheld calculator. So how on earth could you do these? What they had is huge charts that you could look up logs. Like you could look up log base 5 of 26 on a great big chart. You know, you could like flip through this book and find it. It would just be in there. All right. So we'll use the calculator to just know that this is 2.024. And on the test, we're going to be focusing on ones that work out real nice. Like, for instance, do you get, if this had been a 25 right here, then this would have been a 25 right here. And if you saw this problem, you'd be able to go, oh, that means this, and that means this must be 2. And you could have solved it. Now, the way I'm going to do it is like this. If I said log base 5 of, you guys would agree that 25 is 5 squared. You guys get that I just replaced 25 with 5 squared, right? If you can make this base and this base the same, then you have just got the answer, and the answer is already there. It's that. The answer is 2. Remember how it was 2.024? But I just tweaked it a little bit so I could make it equal to 2. Because we're going to do ones you can do in your head. Nobody's going to want to do 2.02 on the test because you'd have to memorize this gigantic chart of logs. Instead, we're going to do ones you can do in your head. All right, George, can you shut that door, please? There's loud people out there. All right, so when you're done with that, set it on my keyboard. Here's another log. Log base 8 of 8 to the 3rd. And I know the answer already, and I bet somebody else does too. Say it if you know it. 3. Now, would you agree 8 to the 3rd is some really big number? I don't even know it. 8 to the 3rd, it's 512. So that means log base 8 of 512 is 3. And it is. Because 512 could be written as 8 to the 3rd. And if this base of the log and this base having a little exponent on it, if those two numbers are the same, they're both called bases in their own way. If those bases are the same, then the answer is already there. All right, so the answer for that one is 3. Another way I could show you this, and again, I think showing you all these different ways, you can pick your own favorite way. I could rewrite this as an exponential. And it would be 8 to the power of, then you jump, wait, I should do my rewrite like over here. 8. And then this whole thing equals x. If there isn't already a variable, you can just say equals x, because I don't know what it equals. Okay? And now watch. 8 to the x. You remember this thing where you go back and forth on both sides of the equation? I call it the circle of logs. 8 to the x equals 8 to the 3rd. And then isn't that kind of logical then that x has to be 3? You know? 8 to the what is 8 to the 3rd? Well, 8 to the 3rd is 8 to the 3rd. X must be 3. All right. So there are like 4 major skills that you have to understand today. The first one is if I give you something like 2 to the x equals 7, you got to be able to write that as a log. Let's see if you can do it already. Write that as a log. So if you're ever confused, just start. Just do one little step at a time. Clearly it starts with a log. And then you start with this thing. It's called the base of the log, and it's the same as the base here. So then I start with 2. Then you may recall that I said to go around the circle of logs. 7 is next and x is last. There we go. Now we know this thing is called the base. This thing is called the argument. just that position is called the argument. And this is called the exponent spot. And I know that feels weird because it's not in an exponent position. But look, see when it was the exponent. All right, so the three names are, this is the base, that's the argument, and that's the exponent. Okay, next thing is to be able to say them. So if I just write this on the board, like even a week from now, kids aren't going to know how to say this. Try to learn how to say it. If you can't even say it, it shows you don't know what's going on. Like it's like when your grandpa says, hey, I'm supposed to like do something with the Wi-Fi, and you're like, what? Oh, you mean Wi-Fi? Because if you can't even say it right, you clearly don't know what it is. Okay? All right, well, let's see if you can say this log right. That's log base 4 of 8. That's how you say that. Log base 4 of 8. But kids are going to say log 4, 8. That doesn't mean anything. Log base 4 of 8. That's how you say it. It would have made sense to me if they would have made you say it log base 4 argument 8, because that 8 is the argument, but log base 4 of 8 is easier to say. All right, so that's how you say a log. That's skill number 3. Number 1 was just knowing what to do to change a log into an exponent. And here comes the last thing, and you just have to get good at. And that's knowing that if I could make the bases the same, then I'll know the answer. That's the base. This also could be a base because, if nothing else, everything has a power of 1. But couldn't I write that 8 in a more creative way? Yes, 2 to the power of 3. That would be a great way to write it because then the bases are the same. And trust me, even more than you know right now, getting the bases the same is the whole thing. When you get the bases the same, then logs are super easy. So we'll make them trickier and trickier, but do you see how I turned that 8 into a 2 to the 3rd? And that's the answer. The answer is 3. And I can show you why. Because if I was going to rewrite this as an exponential, I'd say the base was 2. And then you do the circle of the logs, 2 to the 3rd. And then you come back here, and you say it equals 2 to the 3rd. And you can't argue with that. 2 to the 3rd equals 2 to the 3rd. When you rewrite this thing, it's for sure true. Okay, so this is just plain, like, get used to this. Practice log base 4 of 16. Boom, I got it. Anybody else got it? What's the answer? You don't have to rewrite it as a log. Just tell me the answer. 2. And there's 2 ways you could do it. You could be thinking 4 to the what equals 16. That works. Or you could be thinking 16 is 4 squared. And then this is the answer. And I like that way better. Just because I think it's faster. All right, so let's do another one. Log base 5 of 125. Now this one you might not have memorized, but you might be able to kind of like infer it. What do you think the answer is? If I could rewrite that as 5 to a power, yes, that is 5 to the 3rd, and therefore the answer is 3. 5 times 5 times 5 is 125. All right, here's another one. This is another one of those chapter tests where, like, I feel like this last test, none of the things were really hard. I mean, I had a kid retake a test this morning in 10 minutes, the whole test, and got a perfect paper. Okay, so moral of the story, those questions were quick, but there was a lot of little things you had to know. And to be fair, that test was a retake, so those of you that aren't taking it right now and you're like, it didn't take me 10 minutes, it was a retake, so it makes it a little quicker. But There's a lot of little things to know about logs, but none of them are hard, in my opinion. A lot of little things to know. So here's another little thing. Log base 4 of 1. You can make the bases the same here. You might be like, what? 1? How can I make that the same as 4? How can I make a 1 into a 4? You can't just change a 1 into a 4. Yes, you can. Somebody's thinking it. 4 to the what? 4 to the 0. There it is. Because 1 is really 4 to the 0, isn't it? So then the answer to this one is 0. If you typed on a calculator log base 4 of 1, the answer is 0. And so I got a shortcut for this one, and I actually had a kid come back from college, emailed me and said, it came up again the other day, Mr. Server, and I just wanted you to know. He's actually in pre-med, named Wes. If you're listening, Wes, that's bizarre, but anyway, Wes sent me an email and said, I love that thing you said about 1 in the argument, because it applies in real life. So I'm going to tell you my thing. If you won the argument, you get nothing. Because it actually applies in life too. You can win an argument with your friend and then make them not a friend anymore. You just pound them into the ground, you beat them to death with you're right on something, and then all of a sudden you just lost a friend, and then you won the argument and you got nothing out of it. Shouldn't have even won that argument. There's some arguments you should just walk away from because you're just going to make an enemy. Now there's moments of principle where you got to stand up for your principles and argue something, but there's other times where you're like pepperoni versus sausage, and if it's lighthearted, cool. But if it ends up being that you, and I know this from being married a long time too, if you argue over little things, it's really, really dumb. You get nothing out of it. You might win the argument, get it, and get nothing. So you don't have to go think through, oh, I guess it's 5 to the 0 power, and therefore the answer is 0. You can just know, oh, there's a 1 in the argument spot. 0, boom, done. It's kind of like 5 to the 0. Oh, it's just 1. I don't have to really think about why 5 to the 0 is 1. I mean, I could prove it if you wanted. 5 to the second is 25. 5 to the first is 5. And they're getting 1/5 as big, 1/5 as big. But you don't have to think it all the way through. You can just know, oh, there's a 0 there. And therefore the answer is 1. Okay, so a 1 in the argument spot, boom, instant answer, 0. And true in life too. Don't win the argument and lose a friend. All right, so here's another really, really big thing. Can you say it? I gave you long enough that you may have forgotten. Would you please write out how to say this log? Don't say it out loud, please. Write down on your iPad so that you aren't like Grandpa saying Wi-Fi. At a minimum, it makes you sound like you don't know what you're talking about. Of course you say log. Nate, what's the next word you say? Base is correct. Riker, what's the next word you say? Yep. And this is the critical one. Mason, do you remember it?
Of.
Of. And the final thing?
2.
Yes. Log base 8 of 2. Okay? Gotta know how to say it. And I'm telling you, a ton of freak out kids are going to, their teacher isn't gonna talk about that very much. And if you ask them today to say it, nobody, I swear, I've seen this so many times, nobody knows how to say these. They'd say log 8, 2, and no, that doesn't mean anything. Okay. Or there's other, even worse ways to say it. All right, so now I've said it, but then what's the answer to it? You might be like, well, 2 can't have an 8 for a base. Yes, it can if you get creative. You got it? 2 to the third? Can't say 2 to the third. We want the bases to be the same, so let's get rid of the 2 and put in an 8, and just like we know it has to be an 8, right? 8 to the what? 1/3. 1/3. There it is. Do you get how now they have the same base, and 8 to the 1/3 power is 2. Now, I know that that's a tough one for a lot of kids, because on the last test, a ton of you didn't replace 8 to the 1/3 power with a 2. You were like, I guess I'll leave it as 8 to the 1/3. And I actually allowed it, but 8 to the 1/3 is 2. Yes?
Could you also replace the 8 with 2 to the 3rd, or does that help?
That's a good question. No, you can't replace and make this the same as this by changing this. That's not... Now, I get what you're thinking. I do, because it would be the same idea as making this a 2 to the 3rd. But see, then the answer, you'd think the answer would be 3, but the answer is actually 1/3. Okay. All right, so let's do one more like that. It's a weird one because it has no base. What? You can have no base? Yes, you can have no base. But then that means a base. All right, you guys have gotten smart enough to know that that means square root of 100. You knew that before, but you also now can handle it if I put a little 2 there. Do you get there always was a little 2 there? That's what square root is supposed to look like, because we also have cube roots. We also could do the 4th root. And the square root had a little 2 there. We just didn't write it because it wasn't necessary, because it was the most common square root. And so you just don't ever put a 2 there. You just don't need to, because if you don't put a 2 there, we know it means square root. Same thing here. It's the most common base you could have, which is 10. If there is no base, then the answer will be all about the base. I've seen this on so many ACT tests and so many pre-calc tests. When we give you a log and there is no base, you've got to figure out what the base is, and you will use that to solve the problem. Okay. Now you might be like, how in the heck am I going to make 4 into a 10 to the something? That one isn't easy enough to do. Maybe it's even possible, but I don't even know how to do it. So what if you had an answer like that? Then you would leave the answer like that. You just ask yourself, can I simplify this into a 10 to a power? And if you can't, then you just leave it. And that one I'll do on the calculator for you, just to give you an idea. This, I'm going to go math, alpha, math, and it brings up log with the 2 boxes. I'm putting a 10 down in the bottom, and then I'm putting a 4 here. There was a faster way to do that, but the answer is 0.602. Yes?
So if there's no base, it's always 10? Or...
Yes, if there is no base written, then that means it is base 10, period. All right, so if I said log 100, this is considered a tricky problem, but you should be able to do it in your head. And I think somebody's already got the answer. Raise your hand if you already have the answer. Ah, there's 4 of you that figured it out already. I don't get what's going on. What did I say would be the most important thing to do right away? Find the base. What is the base? 10. Now, can you make the bases the same? Yes, you can. Tully, what's that 100 the same as? I'll give you a hint. You want it to be 10. So 10 to the what? 10 to the first? Is that the same as 100? There we go. So the answer's 2. All right, there's one more weird base you could have, and that's log base E. It is so cool that your calculator even has a button for it. And again, we're not using the calculator, but there is a button on the calculator called LN. That's shortcut for log natural. The natural log. That means when you use a base of E, we will use that one. You have learned that E is close to 3. I said it was so close you could just round it to 3. But it's actually more like 2.718 or 2.7. It's one of those things like pi that goes on forever and never repeats. Okay. So if I just had that, you don't really have to think too much. The bases are the same. What's the answer? But wait a minute, there's no exponent. There's an exponent. 1. The answer is 1. Log base E of E would be 1. What if it was log base E of E to the 4th? Bases are the same. The answer's already there. It's 4. All right. What if it said log of 1/10? And I'm like, there's no base. Well, that's the first thing you should fix. And then you got to get creative with making those bases the same. So Spencer, what is the base? 10. And then we want to make them both have a base of 10. That's the hard part. Can you make this be base 10? 10 to the something? 10 to the negative 1 is correct. She beat you. Do you get that those two bases are the same now? And then the answer is negative 1. 10 to the negative 1 is 1/10. You got to remember all of those, and that's why we do exponentials before this, because it gives us a chance to practice all those weird exponents. Here's another weird one coming. That has a weird exponent? Yes, it does. Square root of 5. What the heck? Think of it as, you know it has to be a 5 to a power. Like when you get stuck, go, well, it's got to be 5. Oh yeah, 5 to the 1/2. Very good, somebody had it. 5 to the 1/2 power means square root of 5. If you haven't processed that yet, this is probably the third time it's come up, but you'll eventually get this. Square roots mean power of a half. All right. So then why'd we do that? Because the answer's already there now. What's the answer? It equals a half. And if you're like, I don't understand why it equals a half. Well, I could put an x here, and I could say 5 to the x equals 5 to the 1/2. And when you write that out, it becomes blindingly obvious that x would have to be a half. Okay, cool. You learned about logs. Now, I decided to just teach it my way. I felt like it would flow better than the slides. So we are jumping right to the homework, which is a Schoology quiz. Let's get it started together. I think you'll find it's not too bad. The one thing I don't think I practiced with you enough was like rewriting them. And it doesn't come up till the end of the Schoology quiz. So why don't you load up the Schoology quiz? And I'm going to show you one more rewrite. If they give you this, the question isn't what's x. The question is, can you rewrite it as an exponent? This is a log. Can you rewrite it as something to the something equals something? You know, and I'm not going to say it's a 5. It's not a 5. Can you rewrite it as something to a power equals some other number? No log involved. Can you take out the log? Yeah, I can. 3 is the base. 3 to the x? No. Remember the circle of logs. 3 to the 4th equals x. That is powerful because look, it's solved for x. X is alone now. And the answer is 3 to the 4th. So rewriting logs was one of the most important things for today. If I give you a log, you got to be able to say what it is as an exponent problem. Because now the answer is just 3 to the 4th, which is 3 times 3 times 3 times 3, which is 9 times 9, which is 81. So the answer is 81. All right, last thing before you, if you are in the Schoology quiz, stop for a second. Just pay attention. I know this is big. If I say 5 to the x equals 11, you have to know what the log is. Iris, it's log, but then what goes here? Yup. And then what's next? Goes right here. It's called the argument spot. 11, very good. Equals? Yes, that's how you rewrite it as a log. This one's in exponential form. This one's log form. Okay, now we've practiced everything. gotta be able to go back and forth. If I give you log form, you gotta be able to make the exponent. If I give you exponent, you gotta be able to make the log. All right, number one. Claudia, would you please read number one?
It says log of 1, or log base 1.
Base? Is it the base 1, really?
No, it's not base, it's just log, and then a 1.
But there's no base?
There's no base.
Then what's the base?
It's 10.
Very good. Log base 10 of 1. Now, this is the one I told you about, the whole won the argument deal. What's the answer? 0. If you won the argument, you get 0. Another way to do it, besides just knowing that and knowing the answer must be 0, is say, I'm going to make this base the same, so it's 10 to the something, and you rack your brain for how can I make 10 to the something be 1? Oh, 10 to the 0 would be 1, and so the answer must be 0. All right. Anders, read me number 2.
Log base 3 of 27.
And then in your head, I bet you right away you're changing this to 3 to a power. What was it?
It was 3.
Yep, 3 to the 3rd. So what's the answer? 3. The answer is the exponent. All right, I think you have the idea. Yes.
What do we do if there's a fraction?
Read me the problem that has the fraction in it. Problem number what?
Number 11 says.
Holy cow! Got number 11 already?
No, I was just skipping.
Skipping ahead? Okay, that's fine.
It says
Read me 11.
log. There's no base.
No base. So what's the base?
It just says 1
Wait. But we should know the base. If it doesn't tell us a base, the base is 10. Okay, and then keep going. 1 over 1,000. All right, so hint, as soon as you're writing the base being 10, you should be smart enough to go, oh, so you want me to write this as 10 to a power so that the bases match. You know what I mean? So 1/1000th is 10 to the something. Well, it's not 10 to the first. It's not 10 to the second. That'd be like 10 to the second would be like 100. 10 to the third would be 1,000. So 10 to the negative third would be 1/1000th. Do you get what happened there? First of all, to get 10 to be 1,000, it had to be 10 to the third. And then to get 1/1000th, negative power. So this is really stretching your ability on making things have weird exponents. All right, so there's number 11. All right, if I do any more, you won't have any homework left. So if you want to ask individual questions, I'll be happy to help. That's all I got for you for today.